Hello and welcome everyone to this eCognition Deconstructed video. Today we're gonna talk about thematic layer operation algorithms and we're gonna have a look at alterations. What I mean with alterations is, in this case, vector buffering. So we're gonna have a look at how you can buffer your vectors within eCognition. We have an algorithm that creates buffers around points, lines or polygons. So you can use all different types of vectors as input. And we're also going to have a look at vector dissolve. So you can dissolve vectors, you can dissolve a single vector, you can dissolve multiple vectors based on overlap or common border. Let's have a short look at vector buffering. So your different parameters that you can set if you do the buffering. First of all, you can set different buffering modes. We have 3 different buffering modes: round, square and miter. Round simply creates round corners, square corners, and miter creates also squared corners. But you can define a miter limit, and the miter limit defines at which distance the buffer gets cut off. And of course, you as a user can define the distance of a buffer: 3 meters, 10 meters, 100 meters. All right. One more slide about the miter, because you have more settings here. The miter limit can be defined when you choose the miter as buffer type, and that's a parameter that defines the distance to cut the buffered shape off. If you look at the figures at the bottom, we increase the miter limit from left to right, from 2 to 8, and you see at the bottom of the buffered area that if you set the miter limit to 2, it cuts off the buffer. If we set the miter limit in this case to 8, it doesn't cut the corner here. And what it means is a miter limit of 2 means it cuts off all points that have a higher distance than 2 times the buffer distance that you defined. So if the buffer distance is 10, the miter limit is set to 2. That means if a vertex is further away than 2 times 10 meters, in this case 20 meters, it's cut off. If you increase that to 8, it's 80 meters, so it's 8 times 10 meters. And with this parameter, the settings, you can alter the resulting buffer when you choose the miter as buffer type. One more slide before we start with playing around in eCognition regarding the vector dissolve. This algorithm dissolves vectors, so we're working with vectors based on overlap or common border. You can also select an attribute to use as a criteria. So it's possible to dissolve all polygons within one thematic layer to 1, or you can choose an attribute within one thematic layer. Let's say you have, for example, 1 column in your attribute table depicting the classification. If you use this attribute for dissolve, it only will dissolve polygons that share the same value within that field. If you leave it empty, it's going to dissolve all polygons. Enough of theory, let's have a look at eCognition. Here we have a project, 4 different bands, we have a few thematic layers, these vector layers, and also point cloud in the project, but we won't touch it in this video. We are interested in the vector layers mainly. And we created the 3 bottom vector layers that you see on the left in this first section: create, convert, remove, delete. That was part of a video that I did before this one. So if you haven't seen this and everything that I'm talking about here is new to you, check this video out before you start or continue with this video. But in this video, we're gonna have a look at the alteration section here in the rule set. And it is split up into 2 sections, buffering and dissolve. So these 2 things that we want to have a look at. Let's first have a look at buffering the roads. So the road that we have here is a line vector. And let's assume you want to create a buffer around your road vector. Maybe because you're interested in corridor mapping around the road. We're going to use an algorithm called vector buffering. Okay. Then we choose as thematic vector layer down here the roads, because we want to buffer the roads. On the right hand side, the parameters, You can choose these 3 different settings, round, square and miter. We choose round in this case, offset distance 3, output layer name, just give it a name as you like, and hit execute. And that's gonna be the result in this case. So we have a polygon vector, that's the output, right? It's a buffer. And the offset distance is set to 3. Let's increase that to 10. And you see we created a bigger buffer around the line, right? Again, creating a buffer in this case might be helpful if you're interested in corridor mapping around the roads. Let's check out the other buffering modes, the squared one. It's set to 3 and you will notice that especially at the corners, it looks different compared to the round mode. Let's change the colors a little bit and adjust the order. And here you see, if I zoom into areas where the road ends, you see that the end of the buffer looks different. So it's squared compared to round. Makes sense, right? So I increase it to 10 as well, so it's comparable to the round vector buffering. And you nicely see at the edges of the road that we have a different buffer type and ending. It depends on what you want, okay? Let's have a look at the third option, the miter. So settings are the same, just choose as buffering mode miter. Let's set the offset distance right away to 10 and leave the miter limit at 3. Check the result and you're gonna notice that at the edges, again, it looks different. So not only where the road ends, but also in the curves, you see that we have more rectangular looking corners right here compared to the squared one and also compared to the round mode. Let's check out another area where maybe the comparison makes more sense. Here at this really tight corner, you see that there's a fairly big difference comparing these 3 different buffering modes. Let's do the same for the buildings, right? The buildings are polygons, just so you see that also works for polygons. You also could do it for points. I don't have an example for the points here, but it's exactly the same settings. Just choose a point vector in the domain instead of the buildings or the roads. First here, I'm again going to create a round buffer around our buildings that are polygons, 3 meters, and you nicely see that we have round edges and corners. Let's check out the squared one. And as expected, the result looks different. So you see, especially here in the corners, there's a big difference between round and square. And now the miter, that's interesting. Let's also set it, or let's set this one to 10 and the miter to 3 and also just the other ones to 10. So we just see the difference better between these modes. And you're gonna notice that the miter is actually more or less resizing the polygons, right? So it doesn't cut off the corners in this case. You get exactly the same shape, but just enlarged by 10 meters in this case. The squared one is cut off and the round buffer has just these round corners. I'm going to show you an example where the miter limit has a big influence on the buffer when choosing the miter as a mode. Let's have a look at this example here. What you see here is a building with a very pointy corner at the bottom here. And the buffer is miter and the miter limit is set to 2. So you see that it cuts off the buffer at this bottom corner here. If we increase it to, let's say, 4, you're gonna notice that the buffer is changing, right? So it only cuts off points that are outside of 4 times the buffer distance. If the buffer distance is 10, it's 40 meters. Now I even increased it to 6 times 10, 60 meters, so it doesn't cut it off. You get a very pointy corner as well in the buffer as you see in the building. So if you're using the miter as buffer mode, be aware of this setting, the miter limit, because it has a big influence on your buffers that result from this algorithm. Let's have a look at the last process here in this section of the rule set. This is the so-called vector dissolve algorithm. In the domain, you define which thematic layer you want to dissolve. It can be one thematic layer, it can be multiple. On the right hand side, you define the output vector layer name, because you're creating a new vector layer, a new thematic layer. And then you can set the settings if you want to override it, if it's already existing. Last parameter here is the criteria attribute. If you set a column in the attribute table here, it will only dissolve if they share the same value within that column. If you leave it empty, everything is gonna dissolve, okay? And let's see how a result can look like. Here I did it for the round buffers of the building, and you see the black outline is the outline for the dissolved buildings and the red one before the dissolve. So traditional GIS operation done in eCognition. Very nice. That's already the end of this video. So we had a look at alterations of vectors within eCognition, especially looking at buffering and dissolve. I hope you enjoyed it. See you next time.